This lizard rivals a Saint Bernard, not just in size, but also in gross slobber. But whereas a Saint Bernard wants to cover you in kisses, this monitor would be more interested in ripping off your whole face and swallowing it in a single gulp. Let's get into it with the infamous Komodo dragon. Hi, I'm Danielle Dufault, and you're watching Animalogic. Today we're talking about the world's largest living lizard, the Komodo dragon. Komodo dragons are one of the over 80 species of monitor lizards, a genus known as Varanus. All of these lizards share some characteristics, like being carnivorous and having long necks, powerful tails, and well-developed limbs. The smallest of all is the Dampier Peninsula monitor, which is just 20 centimeters long. The biggest is, of course, the star of this episode, the Komodo dragon. So now I must ask you, what's the biggest lizard you've ever seen? Maybe it's a 1.5 meter long green iguana that can tip the scales at around 8 kilos? If we want to understand just how large a Komodo dragon can get, we need to double the length of a green iguana and add about 160 more kilos. That's right, the lordiest Komodo ever known clocked in at 166 kilos. That is heavier than the largest dog ever recorded, a Saint Bernard named Benedictine, who was a whopping 162 kilos. Aside from fighting in the same weight class and having mouths dripping with drool, that's pretty much where the similarities between a Saint Bernard and a Komodo dragon end. While Saint Bernards were bred by holy men to save people in peril and are famous for being gentle giants, Komodo dragons are armed, dangerous, and seem like they were dreamt up in hell. Komodo dragons are stacked to the literal teeth with traits that make them terrifying killing machines. Though they aren't usually interested in eating us, an attack from a Komodo dragon is lethal, even for us. So let's break down all the reasons a Komodo dragon should not be messed with. While a Komodo dragon doesn't have the bite force of some of its other reptilian brethren, like alligators and crocodiles, what it lacks in power, it makes up for in sheer intensity. The bite of a Komodo starts with the long, curved, and serrated blade-like teeth to pierce the prey's flesh. And these teeth take the words blade-like to a whole new level. It was recently discovered that Komodo teeth are actually coated with iron. A recent study showed that the serrations of the Komodo's teeth are kept razor sharp thanks to a coat of iron. The concentration of iron is actually so high that these serrations appear visibly orange to the naked eye. To learn more about their amazing teeth, we talked to my old friend Dr. Aaron LeBlanc, the researcher behind the study. So what makes Komodo teeth so special?
One of the weird mysteries is Komodo dragons are well known for being able to tackle prey much larger than themselves and using those serrated teeth to cut off large chunks of meat. But the part that interacts with the food, the enamel, the hard part of our teeth that you and I brush every day, on a Komodo dragon is literally paper thin. It's just a mere fraction of the thickness of the enamel on your teeth and my teeth. But it still clearly performs this cutting function. So we wanted to understand how that works. And in looking at Komodo dragon teeth under the microscope, I realized that the serrated cutting edge always looked stained.
Iron-coated teeth are not as weird as you might think. Some of our neighborhood creatures, like rats and mice, as well as the famously strong-toothed beaver, have iron in their enamel. That's why their incisors look so rough.
I think calling them iron-coated teeth is true. I think that's accurate. A lot of, like beavers, they incorporate that iron into their enamel. Komodo dragons don't. It's like icing on a cake. It's an iron-rich calcium pore coating that tells us it's not in the enamel, it's actually on top. The iron coating itself is 1/1000th of a millimeter thick. But we know it's involved in keeping the teeth sharp because it's only found on the serrated edges of their teeth.
So once they've sunken their mouth knives into the flesh of their prey, They use their powerful neck muscles to thrash it back and forth, ripping and tearing until it is done. Komodo, more like Como Doom. All the while, the Komodo dragon gets their ridiculously long and rigid claws into the slashing and thrashing game. If their prey does somehow manage to escape, the Komodo dragon doesn't need to worry. It just has to bide its time. That's because venom glands in the Komodo's mouth add a powerful anticoagulant to its sticky saliva. The prey will bleed out and be left for Komodo food. This is a new discovery. For a long time, we all believed that Komodo dragons had boatloads of bacteria in their mouths to give their prey nasty infections. This has been officially debunked. Any dentist would be proud of the oral hygiene of Komodo dragons, who do have cleaner mouths than we do. And in an Animalogic exclusive, we got the responsible researcher for that discovery to tell us all about it.
My name is Professor Brian Fry. I'm a toxicologist at the University of Queensland. The venom is there to act in a supporting role to the teeth, because these teeth are incredible. You know, they're double serrated. They're serrated in the forward and the backward sides. We're talking about the venom, where it's basically like you've got a poison-tipped blade now. The poison helps the effect of the blade. With larger prey, the Komodos will attack and then kind of sit back and just wait for them to bleed out. Now, just from the wounds of the teeth, long before the venom would kick in, about 60 to 70% of the prey bleed out in about 10 to 15 minutes, just from the catastrophic blood loss. But our field of observations and that of other groups have shown that an additional 20 to 25% of the prey bleed out from persistent, prolonged bleeding over the next 3 to 4 hours, often being bit repeatedly by the Komodos. And that's due to the venom, the anticoagulant effects of the venom, where these wounds will not stop bleeding. So with the addition of the venom, that means that Komodos have, instead of a 60 to 70% predatory success rate, they've got a predatory success rate of around 90 to 95%, which puts them into super predator level. This is a predatory success rate of animals that are in their natural prey range of almost unparalleled success. It's a higher success rate than an African lion. It's a higher success rate than a great white. This makes them one of, if not the most successful predators still around on Earth. So it's extraordinary, that contribution of the venom aids and, brings them up.
But how are we so sure it's actually venom?
If you look at the picture of any Komodo dragon or any monitor lizard, you'll see a bulge running the lower jaw. And that's this hollow venom gland that's the same venom gland as like the iconic Gila monster or the beaded lizard of Mexico, where these are well established as venomous lizards. It's the exact same gland, producing many of the exact same toxins with the exact same pathophysiological actions.
Makes sense. It doesn't even matter if their prey somehow manages to stagger away and drops dead somewhere secluded. Their incredible sense of smell allows them to sniff out rotting flesh up to 4 kilometers away. And Komodo dragons certainly have a keen sense of smell. The forked tongues aren't just devilish in appearance, they also help the Komodo dragon to determine from which direction a scent is coming. The forked tongue samples the air around it and brings those scent molecules into its mouth to make contact with the Jacobson's organ. If there's slightly more molecules on the left fork of the tongue than on the right, the Komodo knows that the scent is coming from the left. That's so cool. I need that. While it was recently discovered that humans are capable of smelling over 1 trillion scents, our Jacobson's organ probably doesn't play much, if any, of a role for us. That's because in human adults, this organ, also called the vomeronasal organ, is likely vestigial. In other animals, this organ is responsible for smelling pheromones. Because we rely so heavily on eyesight, This scent-based detector probably became less and less important as we evolved. But researchers are still trying to determine its importance for us today. Okay, so now that we know all that, when did we start calling them dragons? In 1910, when Komodo dragons were first encountered by European scientists after they'd heard whispers about a giant lizard in the Lesser Sunda Islands of Indonesia, they called them Varanus komodoensis, meaning simply monitor lizard of Komodo. That is despite describing them as essentially MLOUS, or monitor lizards of unusual size. In 1926, when 2 live Komodos were captured for the first time, it was determined that the scientific name lacked panache. It wasn't the cat's pajamas. It needed some razzle-dazzle. It was then that the plain old monitor lizard of Komodo was first anointed with the title of dragon in the 1927 book, Dragon Lizards of Komodo. And in a way, Komodos are as mythical and elusive as dragons. They only exist on a few islands in Indonesia, with an estimated 2,500 individuals remaining in the wild. So while we may be afraid of Komodo dragons, what we should really be is afraid for these endangered monitors. Those Komodo dragons that live within the bounds of Komodo National Park are much safer, while those that live outside are especially threatened by human populations. While they can run at up to 20 kilometers an hour, we know that Komodos like to keep to their familiar areas and hardly roam too far from home. Females, for example, will always lay their eggs in the same nesting spot. And while Komodos can swim, it seems that they only occasionally set forth by sea in search of a different island home. All of that contributes to their limited numbers. Reproduction is a relatively slow process too. Females reach sexual maturity at around 6 years old, at which point they start producing 1 clutch of eggs per year. To mate, females first begin by leaving scent traces in her poop, which the males will follow. Remember those pheromone detectors on the roof of their mouths? Now is when they come in extra handy. If another male wants to court her, they'll engage in a brutal fight for her affection. But the loser doesn't need to worry too much about dying from their wounds, as Komodos are immune to each other's venom. The winning male will start licking the female gently. If she licks him back, he's cleared for mating. Even if they can't find a mate, Komodo females are more than happy to stay single ladies. That's because Komodo females are capable of parthenogenesis, which is basically reproduction without fertilization. This is possible because female Komodo dragons are born with both male and female chromosomes. The trade-off is that the clutch will only produce male offspring, and too much can lead to inbreeding. The female will lay her eggs in the hole that she's dug for this purpose, and guard her clutch for the first few months of their 8-month incubation. Once they hatch, it's straight up a tree. Komodo dragon babies instinctively flee up trees to avoid being cannibalized by nearby adults, which consider them an easy meal. When they're on the ground, the juveniles will roll around and poop to deter adult Komodos from gobbling them up. That's because Komodos will eat pretty much anything that moves. Or that was once moving anyway.
And this is one of the projects that we want to do next is baby Komodos spend the first year of their life, they're like a crocodile monitor. They're full-time in the trees. So they're feeding on different animals and they're feeding with a different prey escape potential. So do the babies have a venom that's like that of a crocodile monitor where it's more neurotoxic than blood-acting? And does it shift to becoming a more blood-acting venom like the adults as they spend more and more time on the ground and feeding on animals that way? So that's definitely one of the next major projects we want to do is looking at changes through time.
Yep, Komodo dragons may be the world's least picky eaters. Living prey, dead carcasses, small as a rodent, big as a water buffalo, their own kind, bones, hooves, hide. The Komodo doesn't discriminate when it comes to a good meal. and their appetite matches their size. They are capable of gobbling up 80% of their body weight in a single meal. While they are good runners, Komodos prefer to use their stealth and power to hunt. They'll lay in wait along a game trail for hours until just the right candidate for a meal roams by. That's when they launch into attack mode, snatching and quickly overpowering their prey. Despite being cannibals, Komodos will also, somewhat confusingly, share a meal together. Their strong throat muscles and hinged jaws allow them to gulp down huge chunks of a meal in a single swallow. Their stomachs can expand to an enormous size to accommodate all of that meat. These mega meals will sustain them for upwards of a whole month. Imagine if we humans only had to eat 12 times a year? I'd save so much money on tacos. While Komodo dragons are the world's largest living lizard, they are not the biggest monitor lizard to have ever lived. That title, as far as we've discovered anyway, goes to Megalania, which may well have weighed up to 2,000 kilograms and reached lengths of 7 meters. That's the length of a city bus. Megalania roamed Australia during the last ice age, in the era of megafauna. It was so recent, in fact, that Megalania even lived on the continent when humans also started to inhabit Australia. Given the title of largest extant species, it shouldn't come as a shock to learn that the Komodo dragon is the closest living relative of Megalania. While Megalania died out long ago, these two monitors were actually contemporaries. Komodos evolved more than 3 million years ago in Australia, so Komodos and Megalania would have been wandering around the continent at the same time.
So Komodos radiated from Australia out into parts of Indonesia. Megalania didn't leave Australia. Komodos, Megalania, and the other species all went extinct in Australia when the megafauna declined. So the oldest fossils of a Komodo are about 3.5 million years old, and they're found here in Queensland. They only went to the islands in Indonesia about 1 million years ago.
It really makes you wonder, why then are Komodos still walking the earth while Megalania are nothing but fossils, along with Australia's other megafauna? There are a number of theories. Some researchers believe that it was climate change that brought down these giants. However, this hypothesis is becoming more highly contested. Fossil evidence suggests that megafauna populations fluctuated with the changing climate, but that it wasn't the main cause of their extinction. The extinction of Megalania was likely caused by the arrival of humans in Australia. Some theories suggest that overhunting, especially of juveniles, could have caused Megalania populations to collapse. Another theory is that human-made fire could have destroyed megafauna habitats. Basically, the exact same reasons today's Komodos are currently endangered, just fast forward 40,000 years. Unlike back then, however, there are conservation efforts that aim to preserve this monster monitor and its limited habitat for generations to come. Organizations like the Tarragona Conservation Society Australia, the Komodo Survival Program, Global Conservation, and many zoos around the world are trying to keep these lizards alive and thriving. Okay, so given everything we know about Komodos now, I think we can safely say that we all understand that they're not actually dragons. But can we keep the name? It's actually pretty cool, and I bet they like being called dragons. I know I would. Today, we're going to talk about a creature that's taken on so many different forms and probably has many more to go. That's right, we're going to talk about T-Rex's nemesis, Spinosaurus. Just a heads up, this creature has a long and tangled scientific history, and this is just a short version of that and how it's been depicted. So if you need more specifics about the science, definitely dig in, and check out our episode on Spinosaurus while you're at it. So let's take a look at the very first fossils of Spinosaurus that were ever found. These were from 1912 and discovered by Richard Markgraf. So the bones that were found, by no means was this a complete skeleton, but it did seem like they all went together. But these were the weirdest fossils of a theropod dinosaur that anyone had found so far. In 1915, Ernst Stromer published these fossils. It had a super long, narrow jaw and long protruding dorsal spines down its back. Hence, Spinosaurus. Despite being in pieces, it was so weird that it deserved to become the founding member of its very own new clade, the Spinosauridae. I'm gonna guess that the only way that they knew that it was theropod was because of the association of other bones that it was with. Even the teeth that you can see in this illustration, they're so conical and round and robust that they look a whole lot more like a crocodilian than a dinosaur. And we'll be coming back to that later. And then we have this photograph of the vertebrae that were collected, and they put them in, you know, what they assumed would be the best plausible order. And you can see just how crazy tall those dorsal spines are, hence the name Spinosaurus. He's one spiny boy. In 1936, Stromer made a reconstruction of Spinosaurus, trying to make sense of all the bones that were ever collected so far. It leaned pretty conservative because other large theropods were all we had to go by at the time. So at this point, we still didn't have a face, but we knew it had a long, strong chin, some conical, pointy teeth, and it was a tall-spined theropod. But we all started to wonder the important questions, like, could it win in a fight against T-Rex? These bones were utterly lost to history during World War II, when the museum where they were stored was destroyed. Photographs were rediscovered in the 1990s and published in 2006, and during that time, imaginations and paleontologists ran wild. Okay, we're gonna jump all the way to 1976 because no one's really cared yet about Spinosaurus. For some reason, it's popping back up, and Giovanni Caselli decided to make this fantastic illustration. This looks like a wiener dog on steroids, and please tell me, where's the lie? So it's already going pretty wild with speculation here, and I love it. I think it's great. The text here on the page is talking about how the sale might have actually helped Spinosaurus lose excess heat and prevent it from overheating, making it a quicker theropod than other, meat eaters at the time. Considering what they were working with, these illustrations are awesome. They're time capsules. Some of these definitely look more like Dimetrodon, while others don't bother with a sail at all and opt for big protruding spikes. Others, yet again, follow the science published and do a wonderful interpretation of it. Remember that we still only had the Stromer files and some related dinosaurs to go by. By 1984, researchers were already proposing that Spinosaurus could have had a more croc-like snout to catch fish. And all of that was confirmed when Baryonyx walkeri was discovered. This is when we found that the Spino family was bigger than we ever knew. The Baryonyx was pieced together from separate fossils discovered in multiple places. Even though it wasn't identical to Spinosaurus, it shared some very important traits. It doubled down on the whole fish-eating thing. The reconstruction was also more complete than what we had of Spinosaurus. It had more parts of the rest of the body and some kinda average-sized dorsal spines. Lots of the skull was discovered, including the little crest up on its forehead. It gave us a glimpse at the true face of Spinosaurus, and began painting a whole family portrait. I love this Baryonyx paper because it's one of the few scientific research papers that gets a full reconstruction inside the paper itself, and not just, as a cover page or something. So one of the figures is this fantastic painting by John Sibbick. And I love his art, big time fan and big inspiration. He's got this animal looking so naturalistic, and honestly it still holds up really well to what we understand Spinosaurids to be. And that's just it. this was the beginning of the expansion of the Spinosaurid family. So Spinosaurus is no longer living inside its own family all alone. It's got company. I still think that this John Sibbick piece is still one of the best pieces of Spinosaurid art out there. It's honestly just gorgeous. Additional evidence was found when Suchomimus was discovered in Niger. The 1998 documentary Colossal Claw gave us a better glimpse into what scientists were thinking at the time. This skeleton of Suchomimus, or the croc mimic, was 2/3 complete. And as its name suggests, it had a very croc-like face. So at this point, people were starting to connect the dots. Maybe Spinosaurus also looked just as crocky? Considering the semi-aquatic lifestyle of crocs, was this a case of convergent evolution? And just like Spino, it had long dorsal spines too. The environment it came from was a lush, swampy delta, so there would have been lots of feeding opportunities, both terrestrial and aquatic. Oh my goodness, that dramatic zoom. That jaw just goes on for days. Oh, I love that extreme wide-angle lens. This is really starting to take shape for what we understand Spinosaurids to look like now, today. You saw the placement of its nostril, it's higher up on the nose. Just 3 years later, Spino gets his first big break on the silver screen as the main antagonist for Jurassic Park 3. He's here to ruin T-Rex's day and is destined to fight him forever. Although they probably never would have crossed paths in reality. Okay, here comes Spinosaurus. See, this is awesome because even if at this point we didn't have everything that we now know about Spinosaurus, this was perfect timing to put him in a movie because we just got Baryonyx and Suchomimus giving us a face. So now we've got this big spiny meanie with that big croc face. I mean, they did a very nice job, actually. We didn't know yet just how tiny their legs were. So the fact that it was this big upright theropod, you know, running with those big long legs, might not hold up today, but I still think that it was a fantastic model. I think that movie gets a lot of hate. Just admit it, you wanted to see T-Rex fight a Spinosaurus. Good job, the movies. Finally, after nearly 100 years of mystery, Spinosaurus's face was finally revealed. Check out the skeletal reconstruction though. Those legs are looking pretty long still. Something is holding this creature back from its full potential. We just don't know what yet. This is also around the time that old photos of the destroyed specimen were rediscovered in old collections. So everyone got a fresh reminder of where this all began. So you can see here how this has been cobbled together by the bones of multiple Spinosaurus specimens and Spinosaurus cousins, because they're all like little missing pieces of a jigsaw puzzle. But together, they make a lot of sense in relation to one another. So now we've got the jaw, we've got the snout, we've got the little crest on top. The sail is nice and round and crescent-shaped, just like in Jurassic Park 3, which surely was referring to this. And it's important to remember that all of those spines, sail spines, they're all broken. Every single one of them. None of them that we have are complete. So the order in which they're arranged and the degree to which they get reconstructed is going to change our interpretation. And it will keep changing it. Just wait. Just a year later, in 2006, all of the research gets compiled into one amazing documentary. Land Before Time 12, The Great Day of the Flyers. And if you've seen this movie, then please just know you are one of the real ones. Okay, I grew up on Land Before Time. It's definitely one of my favorite movies of all time. Drove my family insane watching it day after day after day. I am who I am. But even I didn't know that these went up to 12. In fact, like, how many more are there? I'm gonna look that up later, for sure. Oh, wow. Oh, this Spinosaurus is a bit of a chunker. They definitely made them pretty wide and rotund, but they're all basketball shaped. So the sail on the back is actually kind of interesting because it looks more like an accordion fan. I've got one of those for hot days. Just fan yourself with a Spinosaurus. So we just had to go and check this because it's very vital information. There are 14 movies and 26 episodes of a series for Land Before Time. So we've got like 40 things to go and watch. Should we start a podcast watch along? Does that sound fun? I think that sounds great. Let's do it. Yeah. On a slightly more serious note, in 2011, we got BBC's Planet Dinosaur, showing us something that very likely did happen. Spinos fishing. Ooh, looks like they're eating some small theropod. Oh, and Spinosaurus is coming in for the steel. Yeah, so they're kind of pointing out that this spine was probably a bit of a weak point in terms of facing off with other theropods. It's like a big Ruffles chip. Yeah, that looks ketchup flavor. And it's interesting, you see it like moving and walking around. So every time its spine moves, you see it kind of bounce and expand and then contract. And so I don't know like how fixed and stable its spine was. It's plausible, but up to this point, I don't think we've seen underwater Spinosaurus yet. One of the really cool fish from the Chem beds where Spinosaurus is from is called Onchopristis, and it's almost always the meal of choice that Spino goes for in the water, probably because these big skate sharks are really interesting. You know, there's sawfish and all kinds of other interesting things in there too. So we've got Fisherman Spino, the pescatarian dino. In 2014, Dr. Nizar Ibrahim and his team published the breakthrough that everyone was dreaming of. The first Spinosaurus skeleton since Stromer in 1915. What's more is that it revealed more of the anatomy that the old destroyed skeleton was lacking. It had a few of the vertebrae with the long sail bones, forelimbs, a pelvis, a hind limb, and even some parts of the skull. These new fossils, combined with new technology, gave us the opportunity to look inside the bones. Aquatic or semi-aquatic animals often evolve a higher bone density. Theropods usually have light, airy bones, but Spino bones were dense. Their legs were short, and their wide feet had long, strong bones, letting it walk on muddy, silty soil like a huge shorebird. Short legs made him a short king. The teeth were conical and thick, like a crocodile. This all pointed at a lifestyle that was closer to that of a croc than to a T-Rex, a truly massive crocodino. This made Spinosaurus a star. Based on these discoveries, Nova released a documentary called Bigger Than T-Rex. Let's take a look at what they did. Oh, now look at that sail. That's very different already, isn't it? Kind of the M-shaped, which actually goes all the way back to Stromer and the way that he interpreted the order of those vertebrae. Wow. So as we can see now, the whole stature and like the way that this animal holds itself is suddenly so different because its whole long sausagey body is way closer to the ground because it doesn't have really long legs. In fact, they were pretty short and stout, which also means that its arms were closer to the ground as well. So they were suggesting that maybe it was able to crawl on those big claws. This documentary was a really big deal at the time. You know, it's unveiling the only individual left of Spinosaurus in terms of like an actual skeleton. And for the first time since the original skeleton was destroyed, we have Spinosaurus to work with again, with all kinds of new stuff. This also got Spinosaurus on the cover of Nat Geo. So the cover and the press release was all done by a good friend and colleague of mine in paleo art named Davide Bonadonna. And he's an incredibly skilled artist who works very closely with the researchers and takes part in it himself. Really, the artwork that he did is outstanding and so detailed and so lifelike. This artwork of Spinosaurus, it really is quite wild, because we've never seen such a short-legged theropod dinosaur. And every time someone says theropod, you're thinking, tall, upright, bipedal. Around this time, we were starting to really understand that, being bipedal doesn't mean that you're totally upright. So it was maintaining its horizontal body plan, but this time it was closer to the ground. So they're really moving into the direction of presenting this animal as being semi-aquatic. It probably spent a fair bit of its time in the water, and maybe that's part of what facilitated its short-legged life. Gets you closer to the water, maybe it makes you a better swimmer.
2017, Doctors Hone and Holtz write a paper trying to make heads and tails of all the Spinosauridae specimens collected, doing everyone a big favor by organizing all this information for a referral down the line in this tangled Spinoverse. They point out that one of the features of Spinosaurids are their massive claws, and they featured this awesome bit of art by Matt von Ruyen, proposing the claws were for a "come at me, bro" free hugs threat display, kinda like a croc-faced water anteater.
In 2018, Dr. Don Henderson decided to test the semi-aquatic hypothesis and created a digital model to see if he could make Spino buoyant in its current form. Let's see what he did. I love these figures of these submerged dinosaurs. Just trying to show, would they float? This paper really suggests that Spinosaurus was a disaster in the water, that if it wasn't constantly moving forward, then it would roll and tip over and wouldn't be able to hold itself up. It also says that even if it exhaled all the air from its lungs, it would still be too buoyant to sink or go underwater. Too many air sacs. In 2020, the plot thickens yet again, because Dr. Ibrahim is back with more Spinosaurus. And this time, he and his team are suggesting that it's the first fully aquatic dinosaur. Let's see what they have. There's actually so much to cover scientifically in this paper, but let's keep it a little short by saying this is Spinosaurus expansion pack. They found more of the Spinosaurus that they published on in 2014. And through extreme serendipity, we're able to recover it from a market and from these fossil sellers and reunite it from the original specimen. It's pretty incredible. And one of my favorite figures from this paper is, of course, the skeletal reconstruction, where we have this wonderfully lifelike and absolutely alien-looking dinosaur. But look at this swimming motion. Look at that tail. So the sail didn't end on its back. Its whole tail also had a sail, kind of like a fluke. So that's how they interpreted it. And this paper was suggesting that it used its tail as a propulsion mechanism to be able to pursue things in the water, to hunt down. With a reconstruction like this, this looks like a water living animal. Oh, it's fascinating. I'm sure it could fit some pretty big fish in that gullet, Yeah, he could fit that whole scuba diver in his gullet. He fit so many scuba divers in this baby.
Their theory was based on 3 main ideas. 1. On land, it would have walked on 4 legs and on its knuckles. Its center of gravity would have been too forward, which would have made it slow and awkward. 2. The tail was shaped like a fin, and it likely helped it propel Spinosaurus when hunting and foraging. And 3. The fossils were all found in coastal or marine environments.
This was further supported by the discovery of a nearly complete tail. So of course, they called upon their buddy Davide Bonadonna once again to make a stunning piece of art. So now we've got a literal Spinosaurus swimsuit edition, and it's a full feature. Like, look at this amazing creature in all of these action poses, hunting all kinds of different fish from its ecosystem. So this piece of art is fantastic. In fact, yeah, look at the sail on the tail. You can tell that it's kind of pushing itself along, and he's going for that Onchopristis because it's always Onchopristis, isn't it? They're pretty cool. Welcome to Spinosaurus Swimsuit Edition, where on the centerfold is a beautiful fold-out featuring full exposed cloaca. Oh, these are so beautiful. I love the colors, the light, the proportions on the animal. I mean, yeah, every one of these poses is a masterpiece. Davida, you've done it again.
The paper even included video of their experiment to see how the tail would move in a water flume. I'd say that's got a pretty nice undulation. Of course, the controversy didn't stop there. Dr. Hone and Dr. Holtz determined that the tail was too weak and the sail was too big for it to be an aquatic pursuit hunter. So they were more likely to be for display, like a peacock tail. Oh look, another different sail interpretation. Funky.
In 2022, Paul Serino and his crew created a fully posable digital model based on CT scan data of Spinosaurus specimens. And this had a full distribution of body mass with muscle, bone, and air sacs. It looked like this. Oh, wow. So yeah, they've actually modeled out different types of materials. So we have the full skeleton in 3D and the soft tissue modeled over and around that, and even some of the muscles inside the body. And each element of this model has been assigned its own mass, its own weight, its own volume, and all of that together, they're able to make slightly more accurate readings or estimates of body mass and size and weight.
The results challenged the three arguments made for the fully aquatic lifestyle. They suggested that it was a stable bipedal animal and too buoyant to swim and dive in deep water. Spinosaurus was probably a land ambush predator and was only semi-aquatic at best.
In 2025, Spinosaurus made another appearance in Walking with Dinosaurs. The new one. Oh, I mean, how often do you get to see Spinosaurus snoozing in the sun, chasing bugs? Oh, wait a second. That's a baby Spino. That is so ridiculously adorable. Oh, it's like a little duckling. Spineling? A little spineling. So they are really reflecting the current thoughts on Spinosaurus, and they were definitely working quite closely with the researchers who are most involved with Spinosaurus at this point in time. I really like this scene because you're seeing Spinosaurus in a more inland environment. It's slightly more arid. Doesn't look like he lives on the edge of the ocean. You see what I mean? But what was that you saw in the background? It was water. So they're by a big river. So you've got one Spino by the shoreline who's looking in the water, probably trying to catch an easy fish going by. But this one's going for a deep dive. And it's going, of course, for poor little Onchopristis. I mean, giant Onchopristis, but still. So instead of chasing at high speeds, it was probably ambushing in whatever way it could. So that was a really impressive scene that encapsulates a lot of the science that's being done here by several researchers, you know. You can kind of compare this bimodal lifestyle to a lot of animals today. Like polar bears, for example. They'll dive in, chase after seals, and catch them if they can. If they spot one from the edge of an ice floe, they're gonna dive in for it. But at the same time, if they see prey on land, they're gonna go for that as well. Also, in 2025, we get Jurassic World Rebirth. In the preview of this movie, you get to glimpse at Spinosaurus, because of course they bring him back. Or several of them? And they're sticking to the aquatic theory. Well, these ones are definitely going for like the speedboat model. You can tell they're fast because they have racing stripes. But I don't make the rules. It's how it is. They're even showing that they work together to coordinate an attack. Now, I don't mean to take the wind out of these Spinosaurus' sails, but you know, this isn't necessarily the best looking interpretation of Spinosaurus that we've seen here today, but nonetheless, I love their movement. I love how they look like powerful speedboat swimmers. Still, super cool movie monster. It's what you get. I am gonna point out though that I thought we all agreed that we weren't going for the super fast swimmer style anymore. Like, you're a little behind. There's been so much interpretation of Spinosaurus and the specimens we've got of it. And you know what? I'm glad we don't know what Spinosaurus looked like for sure. It's fun that we get to keep unveiling little piece by little piece, unraveling this mystery, and even rethinking old concepts that we used to have. It keeps everyone wondering, what if? For over 100 years, Spinosaurus has kept us guessing and fighting over what we think it must have looked like. So, who do you think would win? T-Rex or Spinosaurus? Or this 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 Spinosaurus? So, what should we talk about next? Please let me know in the comments. And make sure you stick around till the end to see some of my favorite speculative biology reconstructions of Spinosaurus.
How did these deadly savanna killers turn into this? In the grasslands of Africa and Asia, these wildcats are feared. Unmatched stalking skills, camouflage to sneak up on any prey, fangs and claws sharp enough to shred anything in their path. And yet, as they got closer to us, their behavior changed a little bit, but their appearance changed a lot. What turned these rugged murderous cuties into cuddly murderous cuties? This is the mystery of the domestication of the cat. As hard as it is to imagine, a world with cats as we know them is a relatively new invention. The construction of the pyramids is as close in time to us as it is to the appearance of the first domestic cat. In evolutionary terms, that's the blink of an eye. The domestic cat's ancestors were territorial hunters that were terrified of people. So what changed to make us open our homes to these solitary hunters and for them to walk on through that door? The story begins with our main character, the African wildcat, or Felis sylvestra libica if you want to be formal. That's where Sylvester the cat got his name. They're a bit taller, leggier, and definitely more athletic looking than most domestic cats, but the resemblance is hard to miss. You'll find them roaming savannas and grasslands across Africa, stretching into the Middle East and into parts of Western Asia. This little predator is to house cats what the wolf is to our modern-day dogs. Like most felines, the African wildcat lives a solitary life, roaming and hunting on their own, and tolerating other wildcats just to make more wildcats. They eat mostly rodents and birds, but if the stars align, they can take down antelope fawns. For a long time, the cat domestication story seemed very straightforward. Cats were domesticated by the Egyptians around 3,600 years ago, just a couple centuries before King Tut. That's where we see the paintings, the statues, the mummies, their absolute Stan-level obsession with all things kitty cat. But newer research suggests that wasn't the origin story at all. In 2004, archaeologists uncovered a grave in Cyprus, where a human was buried alongside a cat around a whopping 9,600 years ago. That, along with genetic evidence, showed that cats had cozied up to humans thousands of years earlier than we thought. likely in the Fertile Crescent, just a boat ride away from the island, long before Egyptian art made them famous. It turns out that all of these traits of the African wildcat, their hunting skills, their range, and their opportunistic style, put them in the perfect position to bump into our other main character, a little friend we like to call humankind. This was at the dawn of a pretty important landmark of our story. 10,000 years ago, in the very same neighborhood where the African wildcat lives, humans were inventing farming. We were shifting away from the hunter-gatherer lifestyle, building settlements, and starting to grow crops like wheat and barley, and eventually livestock too. With these new settlements, humans didn't have to do as much running around. That meant surpluses of grain, and where there's grain, there's rodents. For wildcats, it must have felt like winning the lottery. Their weird, bald ape neighbors were bringing them an unlimited amount of furry treats for them to munch on. A cat's dinner in the Fertile Crescent came in the form of some pet shop-style cuties. Mice, gerbils, hamsters, and one of my favorites, the jerboa. Sure, I see an adorable kangaroo-bunny-mouse hybrid, but the African wildcat just saw an easy, bouncy snack. Over time, the cats that were less scared of humans thrived, getting more food and raising more kittens. In a nutshell, that's how wildcats turned into house cats. But there's a bit of a jump between wildcats living among humans and then physically changing into the domestic kitties we know and love. In terms of domestication, the route the cats took is pretty wild. Domestication is more than taming wild animals. It's also about selecting the traits we want them to pass on to their babies and breeding them to make ever more ideal kitties. The ancestors of most domesticated animals lived in herds or packs with clear dominance hierarchies. Humans could step in, feed them, reward the friendliest ones, and gradually steer the whole group. That's how wolves became dogs. Humans kept the friendlier, more docile wolves close, making them reproduce with each other, and by doing that, created a whole new species. But cats did it themselves. People weren't deciding which cats got to mate or where they lived. The ancestors of domestic house cats, like my buddy Nebs here, probably chose to live among humans because it worked in their favor, and theirs alone. Basically the cat version of your worst date. All take and no give, didn't even ask any questions. Early domesticated cats were likely like the feral farm cats of today, mostly doing their own thing. Humans liked them for their mice hunting skills, which made the relationship at least somewhat mutually beneficial. You know what they say, the enemy of my enemy is a wild animal that will slowly turn into my best friend, but will bite and scratch me every once in a while. But there's another factor, cuteness. I mean, come on, look at this. Scientists call it neoteny, and it's adorable. It means keeping baby-like features into adulthood. Cats with round eyes, compact noses, and playful movements hit our caregiving instincts just like a human baby would. Sometimes even more. These traits aren't unique to domestic animals, but humans tend to love them, and that gives cats a real advantage. Compared to their wild relatives, these house cats look like babies for much longer. It's more than just their cute kitten-like features that domesticated cats exploited. Some of their behaviors play the same card, like meowing. Did you know that adult wild cats don't meow? It's a strictly kitten thing. Domestic cats just kept meowing and turned it on us. Basically, baby talk turned into a negotiation tool. And they only do it to us, not other cats. They even evolved to meow in the same frequencies as human babies cry. They literally hacked into our brains to make our parental instincts kick in so we take care of them. And they do it a lot. Yes, Nebs, I know you're watching this. I'll be home with your treats soon. Purring started as a nursing sound too, and even kneading, that making biscuits motion, began as a kitten's behavior to make their moms feed them milk. It's both a leftover instinct and a surprisingly effective spa treatment. Over time, these semi-domesticated weirdo roommates followed humans as they traveled and traded across the Middle East, eventually arriving in ancient Egypt, where they reached legendary status. In the Fertile Crescent, we mostly understand that cats and humans lived alongside each other. But it's the art from the time they hit Egypt, around 3,500 years ago, that shows humans, from temple priests to royalty, had gone full-on cat lady. But not only were they cuddly companions, in Egypt they were elevated to deities, like Bastet, the goddess of cats, daughter of Ra. It's actually kind of a really cool tattoo, reserved for the most hardcore cat lovers. Let me know in the comments if you have a Bastet tattoo. Her yin and yang energy, gentle, playful cat by day, fierce protector by night, made Bastet one of the most revered deities in Egyptian religion. Entire temples were built in her honor, and families kept cats as a way to connect with her spirit. Harming a cat was even considered a crime against the gods. But there was a darker side to this devotion. Mass amounts of cat mummies have been found by archaeologists, measured by the ton. Some of these cats were sacrificed in religious rituals. But the sheer volume of cat mummies is morbid proof that for the first time, humans were keeping tons of house cats, and they were thriving, until they go meet Ra. You're probably picturing the majestic cats in Egypt as mythical looking, dramatically spotted, winged eyeliner, and maybe even hairless like the Sphinx cat of today. But we here at Animalogic are committed to debunking long-held cat myths. And maybe disappointingly, but in some ways relatable, genetic evidence suggests that the venerated cats of Egypt were probably classic striped tabbies, not a lot different from the average alley cat of today. So when did cats start developing the variety of colors and patterns we see today? The answer is, weirdly, very recently. After the Egyptians worshipped the house cat around 3,500 years ago, felines continued to spread across the world. In the Far East, around the 14th century, one of the earliest recognizable breeds began to emerge, the Siamese. Humans actually had no hand in their development. Instead, their unique appearance developed through a process called genetic drift. It's when a small, isolated population develops random new traits, simply by chance. Siamese cats are actually partial albinos with heat-sensitive coloration. They are born white, but as they grow older, their cooler extremities develop darker fur, forming those signature points. Their almond-shaped blue eyes, slender bodies, and short, fine coats also emerged naturally. In the Far East, there are no local wildcats to interbreed with and keep them looking like vintage cats. So domestic cats went their own way, gradually accumulating the unique coats and patterns we recognize today. Are you sensing a theme here? Cats like to do everything themselves. But if we know humans, we know that they can never keep their noses out of anything for too long. So of course, they had to get in there and make their own mark on our feline companions. In the early 1800s, artists and naturalists like Harrison Weir were documenting cats and noted that breeders were selecting for looks rather than hunting skills or usefulness. It was during the 19th century, mostly in the British Isles, that humans pounced on the trend. So let's lace up our corsets, tip our bowler hats, and take an imaginary ride to the Crystal Palace in London, 1871, to witness the very first cat show showcasing human-created breeds. Around 170 cats were entered, some from pedigree breeds, but also some regular house cats. They were judged both on looks and personality. The winner for Best in Show was a blue Persian, owned by a Mrs. H.P. Villet, but for some reason nobody recorded their name. A bit sad. No wonder it was blue. Since then, cat breeding has mostly been about aesthetics: hair length, color, pattern, or even one with a whole body wax. But it's important to remember that beyond differences in fur and coat genes, there's barely any genetic variance. Most cats could practically slip into a wildcat colony and nobody would bat an eye. Except, of course, for the occasional weird meow when they spot a bipedal human. Or maybe to politely request a sweater for the hairless one. And unfortunately, many domestic cats do that. Domestic cats harm wildlife not only by killing it, but also by mating with it. This is when domestic cats mate with wild cats and make them lose some of the adaptations they need to survive in the wild. The poster child for this is the Scottish wildcat. Once abundant, it's now functionally extinct in pure form, with only about 100 individuals left. Most wildcats there are now hybrids, which means millennia of evolution was erased in just a few hundred years. Dogs, on the other hand, are a completely different story. Bred for thousands of years to herd, hunt, pull sleds, and even rescue humans, they now come in wildly different shapes and sizes. A tiny Chihuahua and a massive Saint Bernard might both be dogs, but functionally, they couldn't be further apart. Dogs are engineered for function in all shapes and sizes. But cats? They're still basically the exact same stealthy, silent hunters their ancestors were, just with a makeover. In the last 20-ish years, advances in artificial insemination and in vitro fertilization have allowed breeders to cross domestic cats with wild species, producing hybrids like the tuft-eared caracat and the leopard-spotted Bengal. Nebs is a Bengal. Bengals are mixes of domestic cats with Asian leopard cats. They're beautiful, but if you're thinking about adopting a cat, consider a regular cat from your local shelter. One of the keys to the cat's success is that even though they're cuddly pets, they're also perfectly able to catch prey on their own. This, unfortunately, is a huge problem in areas where wild cats aren't native. Domestic cats in urban areas eat a lot of birds. In North America alone, cats are estimated to kill 2.5 billion birds every year. That means that over 2/3 of all bird deaths in the region are caused by cats. On top of that, they kill over 10 billion small animals a year. Many are rodents, but some are frogs and reptiles, which are not as abundant. There are several bird species like the Canada warbler, the wood thrush, and the piping plover whose numbers are crashing in part due to cat predation. When cats are left outdoors, they can become feral and invasive and cause immense ecological destruction. Feral cats and outdoor cats have been cited as the main reason for the extinction of over 60 species. The damage is especially catastrophic on islands, with birds that didn't have natural land predators. Today, cats kill over 1 billion endemic Australian animals a year. Because of these devastating numbers, the Australian government is trying to cull 2 million feral cats to protect the local wildlife. In New Zealand, they're part of the Predator-Free 2050, which is trying to get rid of invasive predators like cats, stoats, and possums to protect the local birds. So please, keep your cats indoors. This is needed for bird populations to recover. And even though they have the genes to survive in the wild, as long as you give them lots of love and attention, they have richer, healthier, and longer lives indoors. Back to the history of their domestication, new genetic research is starting to challenge some of the current beliefs about cat domestication. For example, scientists are beginning to find evidence that the cats in the Fertile Crescent may not have been the ancestors to today's house cats. Instead, these early felines were a different species altogether and may have been useful to humans for food and clothing rather than companions. However, these theories await confirmation and are pending genetic analysis of ancient Egyptian cat remains. Today, domestic cats are everywhere, An estimated 600 million to a billion of them roam the planet from pampered pets to feral colonies. It's wild, pun intended, to watch the glow-up of these clever, self-domesticating hunters who went from African wildcats to cultural icons in Egypt to global soft and fuzzy companions, and in some cases, back to global invaders. So whether you're admiring a Bengal's spots, watching a feral colony, or just cuddling your house cat, remember, these little hunters may be tiny, but their story and impact is enormous.
Butterflies and royalty have a lot in common. Both appear regal and majestic, decked out in the finest garb around. Both are completely untouchable, royals figuratively and butterflies quite literally. Both seem perfect on the outside, but have a secret. Strange behaviors and hidden personalities that most are never privy to. But in this episode, we'll be revealing the lesser-known sides of at least one of these two groups. The poop-guzzling, booze-fueled, toxic existence that is being a butterfly. Today we're talking about the subject of every millennial's blown-out hip tattoo, the iconic butterfly. Specifically, we're going to be diving into the little discussed sides of butterflies that are less than savory, as we try to answer royalty or butterfly, who is grosser? Let's start by simply asking, what is a butterfly? Butterflies are insects and are part of the Lepidoptera order, along with their night owl bros, the moths. Their defining features are their massive wings, several times larger than their bodies. There are around 180,000 species of known lepidopterans, with hundreds of new species being discovered every year. If you want to get in the business of discovering new species, lepidopterans would be a great place to start. Our best guess is that there are likely upwards of 500,000 butterfly and moth species out there, flapping around 24/7. Butterflies have the day shift, and moths have the night. Working the day shift is actually a new innovation for lepidopterans. And when I say new, I mean the evolution from darkness-loving moths to sunshine-loving butterflies happened around 100 million years ago. The first royals were only recorded just over 5,000 years ago in ancient Sumeria, so they have a lot of catching up to do. One thing that royals, with their regal bank accounts, and butterflies have in common is that they both love to drink poop. For royals, it's called Kopi Luwak coffee, the most expensive coffee in the world. This coffee has been fermented in the digestive tracts of Asian palm civets and pooped out. Butterflies, however, prefer a poopy drink that is closer to the source. Puddling is the term that we use to describe when butterflies use their long proboscises to funnel up any manner of nastiness. These can range from straight-up puddle water to the fluids oozing out of rotting carcasses, and yes, the soupy parts of a steaming pile of feces. The reason butterflies do this isn't because they're utter freaks, it's all for the minerals, specifically sodium, aka salt, and nitrogen. Even the way they eat is a bit disgusting. Since they don't have teeth and can't eat solids, they have to puke onto their food to soupify it first. Then they can drink their pre-digested salty soup. Why exactly they need these minerals is a big unanswered question in lepidopterology, otherwise known as the study of butterflies. Another big question remains, who did poop guzzling better, the ultra-rich or butterflies? Butterflies have chemoreceptors in their feet, which allow them to instantly assess whether something is a good meal or a perfect place to lay their eggs. Knowing what we do about their propensity for salty sources, having a butterfly land on you might not be the good omen you hoped. We know that butterflies drink human sweat and tears. So if one does land on you and sticks around, think of yourself less like a blessed Snow White and more like a salted pretzel. Even animals have their tears sucked by butterflies. It looks adorable, but really all they want is that delicious salt. On the other side of the spectrum, we have the vampire moths. They're literal bloodsuckers that break mammal skin to slurp up our nutrient-rich blood. Thankfully, as far as I know, no butterflies have learned to do this yet. Okay. Do I even need to state the obvious comparison to royalty here? Because it's common knowledge that royalty has been drinking the sweat and tears of the common folk since the first crown was placed on a head. Being so perfect by outward appearances can get really boring. What better way to combat the blasé existence of royalty, or butterflydom, than with some liquid distractions? Butterflies, just like many royals, have a secret drinking problem. Butterflies, in fact, love to tie one on and get so smashed they'll land in your hair and fly in circles until they fall out of the sky. In the fall, butterflies can be seen partaking in the fermenting fruits of the season. Considering that the entire purpose of their beautiful existence is to mate and then promptly die within a week or two, can you blame them for wanting to drown their troubles? What story of the regal tale of the butterfly would be complete without a true Princess Diaries storyline? There are some species of butterflies that live their larval stages slumming it in ant colonies, surrounded by commoners. Depending on the species, these types of gossamer-winged butterfly larvae will have a range of relationship styles with their ant hosts. The common imperial blue butterfly, for example, has a mutualistic relationship, excreting sugars and amino acids for its ant nurses in exchange for round-the-clock care. Others are commensal, like Delanora ocrescens, which doesn't interact at all with the ants, but benefits from the protection of the colony. And then there's parasitic relationships, like the large blue butterfly larvae, which gobble up ant babies undetected, pupating right in the ant nest before busting out in the spring to wreak more havoc. It's all delightfully twisted. Even though they're daylight cuties, they're real queens of darkness. But how did it all start? Butterflies began as some adventurous moths started flying around during the day, taking advantage of the nectar-oozing flowers that were open with the sun. Nectar-loaded flowers themselves had co-evolved alongside the bees who pollinate them. We know about the evolution of butterflies because, back in 2019, a large-scale analysis of butterfly DNA was done which disproved the previous hypothesis about when, how, and why butterflies evolved. The original theory was that pressure on moths from bats, which also feed at night, became so great that it pushed them to start coming out during the day instead. The thought was that this only occurred after the dinosaurs went extinct, and with their delicate bodies, butterfly and moth fossils are few and far between. Instead, we know with almost certainty now that butterflies were flapping around when the dinosaurs roamed the earth. How many butterflies gently landed on a T-Rex's snout while it was taking a nap? We'll never know, but for sure, this happened at least once. Another major revelation from this study is that butterflies did not originate in Asia as previously thought, but can be traced back to what is now North America. Coming to this conclusion certainly was an international effort. Researchers from dozens of countries worked together to create the world's largest butterfly tree of life. DNA from over 2,000 species and 92% of butterfly genera was gathered. In a dizzying 4D puzzle through place and time, the researchers chased the origin of the butterfly back to when and where they first spread their bedazzling wings. As you probably already know, butterflies begin as eggs, which turn into very gluttonous caterpillars. At this stage, they'll eat as many leaves and plants as they can get their mandibles on. A monarch butterfly caterpillar, for example, will eat 200 times their birth weight in leaves in just 10 to 14 days. For a human, that would mean eating 700 kilograms or more than 1,500 pounds of food in 2 weeks, 50 kilograms or 110 pounds of food a day, instead of the about 1 to 2 kilograms or 3 to 5 pounds the average human eats daily, unless you were King Henry VIII, of course. Caterpillars eat so much food that it's actually becoming a problem for the environment. A study from the University of Cambridge revealed that caterpillars and their insatiable appetites are a driver for carbon emissions. Not only do they munch away leaves that convert carbon dioxide into oxygen, their poo, called frass, acts like the perfect fertilizer for microbes that release yet more carbon dioxide into the air. Once the destructo mode is over, a caterpillar encases itself in a chrysalis before transforming into a butterfly. But what is actually going on inside that self-made body bag? Inside the chrysalis, the caterpillar as we know it disintegrates completely, turning into a kind of caterpillar soup dumpling. Not everything dissolves though. A 2013 study in which CT scans were taken of active chrysalises showed that key parts did not morph into goo. The tracheal tubes used for breathing, for example, didn't liquefy, but stayed essentially in the same spot, just getting bigger for the butterfly to breathe. The gut, too, stays in place, shrinking because the days of overindulging are now over. Imaginal discs, which will form the structures of the butterfly, are also present in the caterpillar before the great gooifying in the chrysalis occurs. It all begs the question, How can a slop bucket of parts turn into one of the world's most wonderful creatures? I'm talking about butterflies here, of course, not royals. A big part of the reason butterflies are so beautiful is that they have such colorful and unique patterns. But even that has its nasty side. To keep themselves out of the mouths of their enemies, many butterflies use apposematism. This is exactly the opposite of using camouflage to blend in with the background. Apposematism, also known as warning coloration, screams in bright colors and eye-popping patterns. Eat me and suffer the consequences. The monarch butterfly is the perfect example of apposematism. Bright orange with shocking black and white patterns warn of grossness or even illness if eaten. If a young bird decides to sample a monarch, they will soon learn that they should never snack on something so disgusting again. Monarchs are toxic because of the milkweed they ingest, which contains toxic compounds called cardenolides. As the caterpillars fatten up on milkweed, they absorb these compounds, making them not just vile to the taste, but they'll even make the predator vomit. I guess a butterfly just has to hope that it's not that first one that teaches the bird a life lesson. Other butterflies, like the pipevine swallowtail, eat so many chemical weapons during their caterpillar stage that they remain toxic after metamorphosis. Some heliconius butterflies go a step further, and in addition to eating and retaining toxic compounds during their caterpillar stage, they're able to produce their own poison. And just like the monarch, their beautiful coloration warns predators to stay as far away as possible. So when we humans see a monarch, we see a regal beauty, while the birds that have dared to eat one see nothing more than a pile of puke. Unless they're a black-headed grosbeak, of course, who have evolved to eat monarchs like potato chips. While some butterflies have who they really are on full display, others pretend to be something else entirely. In the animal world, this is called Batesian mimicry, in which a harmless mimic impersonates a poisonous or toxic model. There are many species of butterflies that use this tactic. The harmless, red-spotted purple butterfly looks like the toxic pipevine swallowtail. The female common Mormon butterfly mimics the toxic common rose butterfly. What about the viceroy butterfly, who looks almost identical to the monarch? Well, researchers have recently determined that since it's also distasteful to predators, the viceroy is an example of two toxic species that evolved to look more alike. This is called Müllerian mimicry. What would you call it when this phenomenon happens with royalty? Another imitation game that these tricksy butterflies play is using fake eye spots to trick would-be predators into thinking something bigger and badder is lurking around. Owl butterflies are particularly good at pretending to be something else entirely to protect their true identities. No matter how you spread it, a propensity to suck dry, a taste for the unusual, and a need to escape are characteristics shared by both royals and butterflies.
Behold, the greatest impersonator of the animal kingdom. This small cephalopod can be found in the shallow waters of the Indo-Pacific. Or maybe more accurately, it can't be found in the shallow waters of the Indo-Pacific. That's because it's often pretending to be something else entirely. This is the master of disguise, the mimic octopus. The mimic octopus is an underwater changeling with the power to seemingly transform into other species at a moment's notice. At just 60 centimeters maximum, the mimic octopus, officially known as Thalammoctopus mimicus, is quite demure compared to its largest cousin, the giant Pacific octopus, which can reach up to 4 meters across. Most octopus species share the ability to change their color, shape, and texture in the blink of an eye. In the case of the mimic octopus, they take it a little further, doing a complete quick change faster than you can say, "I'll have the octopus ceviche." Camouflage in nature is used to help prey avoid being eaten. In some cases, camouflage is also used by predators to get close to prey without being detected. This adaptation is a serious evolutionary flex. Camouflage tactics usually involve blending in seamlessly with the background. But for a creature as talented as a mimic octopus, the point of changing its appearance isn't to blend in. It's to stand out and scream, "Come at me, I dare ya!" Researchers have reported seeing these octopuses transform into everything from mantis shrimp and giant crabs to seahorses and starfish. But their preferred disguise is that of creatures that are packed with dangerous venom. This intimidating facade ensures that any predators floating by are fooled into thinking this otherwise delicious octopus is something that's definitely not on the menu. Like many adaptations, the mimic octopus got so good at mimicking because of its chosen habitat, in the open sandy shallows near river mouths. These areas are teeming with predators like large bony fishes, sea snakes, and sharks. To stay hidden, most of the time they'll either be peeking out of their burrows or camouflaging motionlessly with their surroundings. But as soon as they have to move, their cover is blown. That's when it becomes very important to pretend you're someone else. The octopus, for example, puts on a venomous disguise, dressing itself up as a lionfish. After matching the lionfish's distinct stripes, the octopus mimics its venomous spines by holding its flattened tentacles up around its body. Not many creatures have the blind courage to swallow a spiny and venomous lionfish, so this disguise works quite nicely as a warning to would-be predators. Here, the octopus raises its crimped tentacles to mimic a sand anemone, which packs a toxic sting. In order to sell the deception, the mimic octopus does more than just transform its appearance. It even adopts its target species' movements and behaviors. Hey, it might not fool you, but it certainly fools its predators. When it transforms into a venomous jellyfish, for example, the mimic will wave its tentacles the same way a jelly does, as it propels itself upwards through the water. Here, we see a mimic octopus transforming into a banded sole before our very eyes. By holding its arms flush against its flattened body, the octopus can easily pass for this poisonous fish. When in soul mode, the octopus glides across the bottom just like the fish to fully sell its clever disguise. Here, an octodaddy takes the shape of one of the world's most venomous snakes, the banded sea crate, to ward off potential predators. It achieves this threatening look by pulling 6 of its tentacles out of sight and stretching out the remaining 2 in opposite directions. It then, of course, dons the striking black and light gray stripes that are the hallmark of this highly venomous snake. Here is a mimic octo pretending to be a moray eel, a fish that packs a powerful bite and whose colors resemble those of venomous snakes. So this octo may actually be mimicking a non-venomous eel, who itself is mimicking a venomous snake. Things can get very meta on the seafloor. If mimic octopuses weren't shape-shifting enough, they are often mistaken for their closely related but smaller cousin, Wonderpus photogenicus, otherwise known as the Wonderpus octopus. Admittedly, they do look quite similar, but there are a few small differences, most notably the long eye stalks of the Wonderpus, which give it an adorably cartoonish look. Both the Wonderpus and the Mimic have Oscar-worthy acting abilities, but even though the Wonderpus has more charisma, the Mimic seems to have more range, at least for what researchers have observed in the wild. Octopuses can color change thanks to specialized cells called chromatophores, located just below the surface of their skin. The center of each chromatophore cell contains a sac of pigment in colors like black, brown, orange, or yellow. To change color, each sac stretches or shrinks to give the right hue. Not only can octopuses change color, they can also change texture. Projections on the skin, called papillae, adjust to create textures ranging from smooth to bumpy. A true testament to their ability to hide in plain sight is the fact that mimic octopuses weren't even discovered until 1998. Our very limited experience with these incredible mimics means that we're just at the beginning of our understanding of what they can do. Right now, we don't even know for certain the extent of the mimicking capabilities of these octopuses. Scientists believe that we've only seen a fraction of the disguises these mimics can do. Who knows? Maybe your favorite YouTube show is run by mimic octopuses pretending to be nature documentary filmmakers.
Need some great news? The animal you're looking at is not stuffed or an alien that just crashed on Earth. It is 100% real and from this green Earth. Meet Australia's greater glider, the largest gliding marsupial in the world. Ready to make your heart float, this Muppet-like creature is so unbearably cute. It even comes with a necessary disclaimer that it's not made by AI, but by the incredible power and creativity of evolution. So what makes an animal look like this? Let's get into it. Often called flying koalas, greater gliders are known for their good looks and graceful feats, and their popularity is starting to take off. In 2024, they were named the Marsupial of the Year, beating legendary cuties like the Tasmanian Devil, the Numbat, and the Marsupial Mole. Wait, what the heck is a marsupial mole? Okay, we 1000% need to make an episode about these guys. They look like a yeti's finger that fell off and got turned into a sentient furry worm. Wild. But back to the belles of the ball, the greater gliders. Outside of Australia, most people don't even know they exist. It's time to change that, because the greater glider is endangered. In some areas, their populations have dropped a massive 80% in the last few decades. So we asked one of the world's top experts to tell us all about saving the greater gliders.
Hello, I'm Dr. Anna Grassman, and I'm a research fellow at the Australian National University, and my research focus is on the endangered greater glider.
Dr. Grassanin spends more time around them in the wild than pretty much anyone else on Earth. And she has a very clear vision of what makes them so great.
They are just so cool, and they just look such weird, gremlin-y, Ewok, Furby-looking creature. Like, that doesn't look real. That can't be real.
But their cartoon-like ears, magical eyes, and bushy tails are the real deal. These features serve fascinating evolutionary functions, helping the greater glider see, soar, and steer their way through the treetops of eastern Australia. Endemic to the land down under, just like other adorable Aussie weirdos, like the quokka, the wombat, and the platypus, the greater glider is one of the most interesting animals on the planet. But it hasn't always gotten the credit it's due, until now. Is the greater glider the greatest glider?
I think so. I think the greatest glider is definitely the greatest glider for a number of reasons. It's the largest gliding species in Australia. We have a lot of gliding animals like sugar gliders, feather-tailed gliders, yellow belly gliders, and they range in all different kinds of sizes and what they eat and where they are. But the greatest glider, the greater glider is the largest one of them all in Australia.
There's actually 3 separate greater glider species, all adapted to different climates in Australia. The southern glider, from the cooler forests of Victoria, is fatter. Their fur is long, with locks as long as your cell phone, and darker than the fur of its cousins. This fluffiness turns their gliding membranes into warm blankets, and they use them wrapping themselves up like a burrito. The northern glider, from the scorching hot tropical forests of far north Queensland, is tinier, less furry, and has an iconic cream-colored belly. They have smaller ears than their southern cousins, but small is a relative term when you look like Mickey Mouse. And the central glider is the middle child of the family. They're in between the other 2 species, but they stand out because of their silvery brown coat. To people in the northern hemisphere, they might look like bizarro versions of squirrels, but they're much bigger than that. At about the size of a cat, the greater glider holds the title for Australia's largest gliding animal, and is just shy of the worldwide spot at number 3. Topping the list is the giant flying squirrel, followed by the woolly flying squirrel, both found in the forests of Asia. Yeah, we'll add giant flying squirrels to the list of future episodes. The best time to see these cuties is after sunset. At night, they unleash their special powers to sail through the forest canopy, looking for the finest eucalyptus trees to both eat and nest in. In practical terms, they're kind of like gliding koalas. To glide, they use a membrane called the patagium that connects their feet to their hands. It's a feature that convergently evolved in bats, flying lizards, pterosaurs, and of course, flying squirrels. And while this gliding membrane can make them look like superheroes in the skies, it can also make the greater glider a bit bumbly on the ground.
So greater gliders are often referred to as the clumsy glider for a number of reasons. When they are on the ground, they move very clumsily because their gliding membrane attaches from their elbow rather than from their wrist. And so that means they have these awkward movements if they ever do come to the ground.
Now I can see why they stick to the treetops. Greater gliders can cruise for up to 100 meters, the length of a football field. That's more than 200 times the span of their bodies. With those stats, their frequent flyer miles must be seriously impressive. If we could glide that far, we'd be able to traverse 4 American football fields, or 2 Australian footy fields, just to have a comparison the gliders would understand. Of course, there's a reason they aren't called greater flyers. They simply can't move upwards in the air. The glider moves more horizontally and downwards, and its steering is controlled by their bushy, boa-like tails. These tails are huge, almost twice the size of their bodies. Acting like rudders, their tails help them change direction by up to 90 degrees mid-glide. Unfortunately, since they're so big, their glides aren't very efficient, and they fall 1 meter for every meter they move horizontally. Once they reach their destination, they stick their landing by shifting their body upwards to make it easier for all 4 feet to touch down on a tree trunk. Kind of like the landing gear of a plane. And can I just say, the glider achieves these feats through the magic of nature without any bodysuit enhancements. I'm looking at you, Olympic ski jumpers. But aside from being the funnest way to commute, why do gliders evolve this unique mode of transport?
There's a number of theories around why species evolve a gliding membrane and the ability to glide, and probably one of the key ones is that it's an energy efficient way to travel. Now, the greater glider eats eucalyptus leaves, which is not a nutritious source of food at all. So similar to the koala that eats eucalyptus, they have to sit and digest a lot of food to be able to get enough protein from these leaves. So because of this, they don't have the biggest energy reserves. So by being able to glide from tree to tree, it helps to reduce the loss of energy. And another theory for the development of a gliding membrane is to avoid predators, so they can escape.
To avoid becoming a meal, the greater glider's been honing its acrobatic skills for around 18 million years. That's when it adapted to split off from its closest relative, the climbing ring-tailed possum, and set its sights on the skies, or at least the 100 meters of sky between large trees. Don't feel too bad for ring-tailed possums, though. They can eat a much broader diet, including leaves, flowers, and fruits. So even though they don't have as much fun gliding, they don't need to travel as much to find food. They actually have all their fun snacking. Relatable. Like other gliding animals in Australia, the greater glider evolved their aerodynamic capabilities by being forced to leap from tree to tree during a time forests were getting less dense due to changes in the climate. Walking on the ground was not an option because of predators, like the Tasmanian tiger and the Tasmanian devil. Both of these animals lived in the mainland until just about 3,000 years ago. A blink of an eye in evolutionary terms. Today, they're gone from the greater glider's habitat, but dingoes and introduced species like cats and red foxes could easily snap them up. So, soaring through the sky is relatively safer, but threats can also come from above. The main predator of the greater glider today is the powerful owl. The name might seem uninspired, but it's also very appropriate. They're the largest owl in Australia and catch prey as large as koalas. To fight back, greater gliders have become real estate tycoons. They've been recorded using up to 20 different hollow trees in a single territory. They use them at random to hide from the owl.
These are large old trees that have hollows, and they're referred to as hollow-bearing trees. And they rely on them every day for shelter. So during the day, that's when they sleep, And so they go inside of these trees, and there are these big holes, and they're often quite deep and like complex. And dig inside these trees, it's a lot cooler. And so they have a safe place to shelter, to sleep, and to stay out of the heat of the day, and to avoid predators as well.
This is why these trees are such important homes for the gliders. And if those trees disappear, the gliders are in a heap of trouble. This is just a little foreshadowing to some of the issues that gliders are facing, but we'll come back to that later. For now, since we're talking about tree hollows and nests, if you thought a full-grown greater glider was cute, you might want to sit down for what we're going to show you. A baby greater glider! This is a greater glider Joey. He still doesn't have a name, but his parents, Pip and Milo, are over the moon with him. His sibling Brimey thinks he's okay. The Joey is the mere size of a jelly bean. Unlike other marsupial babies, these little guys and gals are born blind, hairless, and underdeveloped. As it grows, it learns to groom its parents and sibling. It gets lots of cuddles. And it learns to eat the delicious eucalyptus his parents bring him. So they hang out in Mom's protective pouch for 3 to 4 months before gliding into the big leagues. Training season begins by hitching a ride on Mom's back. In the meantime, you can see the family grow by following Anna's live stream. We'll add the link in the description.
The babies hold onto their mum's back when they're really little, called back babies. Gliding species and fossil species do this a lot. So they're just hooked on tightly onto mum's fur. And then I've seen it happen. The mum jumps into the air, glides, and the baby is holding on for a dear life. And the baby's back legs stick out, and it's kind of like gliding as well, but just holding onto mum's back as it glides. It's hard to know when will be their first glide, but yeah, they do get practice in when mum just suddenly, spontaneously leaps into the air, and they're like, oh, hold on.
If only we could all get around by hitching a ride on a furry backside. What a wonderful world it would be. I would ride it straight into the pit of despair to save our tax. If you understood that reference, it's time to start thinking about booking regular colonoscopies. Around 9 months old, these Joeys will be ready to cruise solo. And in another 1.5 years, they will have fur babies of their own. It takes about 1 year for them to grow into their massive ears.
There's a couple of theories around why some species develop really large ears. Yes, it can help with detecting sound better, but also with greater gliders, it can be potentially a way for them to deal with heat. So by having large ears, they can help send warm blood to their ears, and that helps the heat to escape their bodies because they are quite heat sensitive.
The ears are adorable and also very useful. And who can't love those big, bright eyes? Described as sparkling stars, they give the greater glider pristine night vision when in search of a foliage feast. Eating a diet of fiber-rich eucalyptus leaves, the glider relies on bacterial fermentation in their gut to break them down. Koalas do this too, but unlike the gliders, they need to develop the skill by eating a special poop from their mother called pap. This gives koala joeys the microbes they need to digest the leaves that would otherwise be toxic. Ready to wash that poopy fact down with another? Greater gliders are teetotalers. They never drink. They have adapted to get all the moisture they need from the leaves that they eat. Though they leap at the chance of getting a fresh meal, these foodies won't be holding any dinner parties anytime soon. Solitary in nature, they only pair up during mating season, from March to June. These strong silent types are just that, and don't make a peep. With no distinctive call, researchers think the greater glider has other ways of making themselves heard.
We believe that one of the ways that they communicate is through scent marking. And they also just, keep their ears out to hear for any other gliders because they're quite territorial as well. And if they hear something and then they see something and they go, oh, that's a glider right territory, they're likely to go and attack them and chase them out of their home.
But just because they like their alone time doesn't mean they aren't characters. Dr. Grassanin knows firsthand from climbing up trees and having sleepovers with them.
There's like a lot of different personalities. So there are definitely gliders that do not like the disturbance, and so they bunker down and hide and go into their little side tunnels and side changes. Other times they are so oblivious to what's going on. And then there's also feisty ones. So I've done some genetic research. We've had to physically capture the animals to be able to get a small tissue sample from the edge of their ear. And when we capture them, sometimes they're just a bit like, "Ooh, I've been caught. What's going on?" And other times they are lashing out with their really sharp claws and biting hard with their really sharp incisors. So I've got a lovely scar on my eye from one bite. And I've also got a scratch on my eye from my glider claw as well. So yeah, lots of different personalities, from very passive to very aggressive.
So, no matter how adorable they might look, or how toy-like and cuddly they actually are, please leave them alone if you ever are lucky enough to run into a greater glider. This is important because sadly, the greater glider is under threat. Remember those hollow eucalyptus trees they call home? They take hundreds of years to grow, and many of them have been destroyed by forest fires or human activity.
What's happened is, for the past 200 years, since colonization, we've had extensive land clearing across Australia, across the range of greater gliders, and that's leading to a hollow deficit. Greater gliders only typically live anywhere between 7 to 11 years in the wild, so they can't wait 100 years for a tree hollow to form. They literally just don't have a place to live. So you have these population crashes occurring.
To make matters worse, devastating wildfires have burnt these trees that the glider and other Australian animals need to survive. In 2019-2020, one of the most catastrophic bushfires in the nation's history hit Australia, impacting or killing up to 3 billion animals. For the greater glider, almost 30% of its habitat was lost. These fires, known as the Black Summer, were a key driver of the greater glider being put on the endangered list in 2022. In human terms, 1 out of 3 houses in your city burned down. It would be a catastrophe, and even worse for gliders, they have nowhere else to go. But there is good news. Building new homes for the animals is giving hope. Dr. Grassanin and other researchers are carving out innovative new places for the glider to live.
So for a long time, conservationists used nest boxes as a way to augment systems and have more hollows, more dense spaces for these dependent species to live in. They're really nice wooden boxes that are insulated. We've put fire retardant paint on them, solar reflective paint to make sure that they stay cool. These are really high-tech boxes with ballistic features to try and mimic that special habitat.
There are different teams setting up boxes in their local forests. Wildlife Queensland, for example, installs boxes at Sheep Station Creek Conservation Park and tracks visitors. They're like a nosy neighbor who knows when you leave your house, but they do it for conservation. These new homes are not only protecting our furry friends, but developing a whole new community of human friends for the glider. As more volunteers have pitched in to become carpenters, they're falling in love with this incredible animal in the process. And what do we do when we fall in love? We tell people! Shout it from the rooftops and the treetops! As more and more people take interest in the greater glider, the better chance it stands at rebounding through awareness. So what can you do to become the greater glider's wingman? If you're lucky enough to live in Australia, you can try spotting them yourself with a citizen science group and track their behavior. With more field data, we can better understand the gliders and what they need to survive. And no need to get FOMO if you live on the other side of the world. You can watch a live stream instead and watch for as long as your heart desires.
I think step one for the greater glider is to help put it on the map. You know, you can't protect what you don't know, so we need more people knowing that, one, the species exists, and so there's a number of things you can do locally or remotely. So signing petitions to help end native forestry logging, signing up a citizen science group to help with surveys,
The best news is, these actions don't only help the greater gliders, they help the whole forest.
They're also indicators of a healthy forest. That means that it's an old, mature forest, and these forests are generally more biodiverse, more stable, better microclimates, a whole number of factors. A mature forest has habitat complexity that allows for more biodiversity to coexist.
Though it's flown under the radar for far too long, there's no shortage of ways the greater gliders can amaze us. More observations of these 3 species means more photos. More photos means more cuteness overload. And more talk about how we can save them. So, what should we talk about next? Please let me know in the comments, and don't forget to subscribe for new episodes every week. Thanks for watching, and see ya! This lizard rivals a Saint Bernard, not just in size, but also in gross slobber. But whereas a Saint Bernard wants to cover you in kisses, this monitor would be more interested in ripping off your whole face and swallowing it in a single gulp. Let's get into it with the infamous Komodo dragon.